So my name is Maxim. I'm working for the company called Pelark, and if you have a DevOps Kubernetes SRE related problem, we can help you by either consulting you or providing you a team of engineers to solve the problem for you. But this is work, and in my free time, I usually contribute to open source projects, features that connected to authentication, security, observability, or maintain the project which is named DEX. And my today's topic will be about exchanging third-party tokens in DEX and how it helps you to build a secure cloud-native environment. Introducing myself with a couple of jokes done. Let's move further and talk about what is DEX all about. There are some facts. DEX was originally developed by the CoreOS company back in 2015. It's already 9 years old, and if you remember the name of the company, you're probably not also new to the industry. It's community-driven project since 2018, so after CoreOS acquisition, it became a community project, and it was donated to Cloud Native Computing Foundation, and it is a sandbox project since June 26, 2020. We have more than 9K stars, more than 1K.6 forks, and more than 25 adopters I personally know about. The main idea of DEX. People usually say that DEX is identity provider or authentication server, but it's not quite right. The more accurate definition is that DEX acts as a portal to other identity providers through connectors. This lets DEX defer authentication to LDAP servers, SAML providers, or established identity providers like GitHub, Google, Active Directory, Okta, and others. And the idea is clients write their authentication logic only once to talk to DEX, and then DEX handles the protocols for a given backends. So you don't need to write integrations with all the existing providers. Basically, the main idea of DEX is this picture. On one end, we have a standard OpenID Connect interface, and we can plug any different protocols you want. There are a lot of supported protocols in DEX. And this is all DEX. Why do engineers love DEX? The first thing is that DEX is ultralight. It's a single binary written in Go, approximately 35 megabytes, no dependencies. And DEX is simple. The code itself is simple. Concepts that lie under, like inside the DEX, are simple. You can read the code for basically 2 hours, and you will understand how DEX works and what it's inside. DEX is Kubernetes native. It was developed to run inside Kubernetes, and it integrates well with Kubernetes. This is much like a hard, yeah. DEX is also a community's building block. It's not only used by companies, but also by other tools in our cloud-native environments, like, for example, Argo CD or SIG-Store or others. And DEX is true open source project. It's community-driven, not owned by a company. We are working under this project without salaries, and we are proud of it. Yeah, this is why engineers love DEX. A little bit about DEX architecture. In the middle, we have DEX, and the first concept is standard OpenID Connect interface. There are a lot of OpenID Connect libraries for all the languages. You will not struggle finding one to communicate to DEX. And we can authenticate users using authentication code flow, or we also can authenticate machines using other flows like password flow, device code flow, or the token exchange that we'll be discussing today. The second concept is storage. DEX is stateful service, so it needs to store its data somewhere. And because the database schema is relatively easy, so there are not many relations between tables. You may use different solutions for storing data. The first thing is good old one relational database. You can use PostgreSQL, MySQL, or who am I to judge you, SQLite. The second solution, if you want consistent and replicated database, you may use etcd. If you are running DEX inside Kubernetes, you can use Kubernetes as a storage backend. So DEX can use custom resources to store its data inside Kubernetes, which is pretty cool. And if you don't want to use any solutions, you just want to test something, you don't care about saving your data, you can use in-memory storage. It's not persistent, but for test, it does the job. And the final concept that DEX has is connectors. And through connectors, we connect other providers to DEX. For example, if you are a big enterprise company, you probably already have LDAP catalog, or you have a key cloak managed by a team of 9 to, I don't know, 90 engineers. How many you need to run key cloak these days? Or you're paying a lot of money to Okta. So you can connect anything existing in your infrastructure to DEX. If you're a small company, you only work on your code in a Git repo, you can use your favorite Git provider as authentication provider. Or if you are just playing around locally on your Raspberry Pi or just testing, you may use local connector or mock connector if you want. They're just for tests. And this is all DEX. Telling what DEX is about done. Moving forward, explain what token exchange is. The token exchange grant, it was defined in RFC 8936. It's extension RFC to original OAuth 2.0 RFC. And these all RFCs describe how you are getting tokens from your identity provider, like exchanging your tokens for credentials or other things. But before explaining what is token exchange, let's talk about the real world concept that all you know about, currency exchange. Imagine you have a euro. And if you're a software developer, probably you have many euros. And if you are a good software developer, probably you have even more euros. But it was before you paid taxes, so now you just have a normal amount. And these euros, they are issued by European Union. There are special signs, and you can validate your money. And this is established currency in European Union in many countries. So if you want to travel to France and buy croissant, it's possible, right? But what if you want to go to Japan and enjoy sushi? So it will not work because there is a different currency. And in our world, there are many different currencies we have because of the geopolitical reasons, because it's just how the world works, right? We cannot have a single currency everywhere. What we can do in this situation? There is some suspicious guy called currency exchange. You may give this guy your money. In exchange, this guy will give you back a yena. And with yena, you can finally travel to Japan and enjoy your meal. And now it's a Scooby-Doo moment, so let's rip the mask off, and I tricked you. This whole time we were discussing tokens, servers, and this suspicious token exchange guy called DEX in the middle. Okay, token exchange in DEX, how it works. First of all, it was implemented by our fellow community members, so thanks them for this good feature. It was merged in November 2023 and available in January 2024, so this feature is pretty new. It works with any kind of JWT tokens, and to perform token exchange, the only limitation that DEX need to have like to communicate with OpenID Connect discovery endpoint. So there is a special discovery endpoint that is used to discover data about OpenID Connect providers like issue or JVKS URL to fetch keys. This is the only thing needed. The idea is that you have a JWT token signed by a different provider, for example, by Kubernetes. And based on the claims of the token, if the signature is valid, if DEX can validate the signature of the token, it can exchange this token for DEX own token. And in the token, you can form the claims that way that they will be based on the claims from the original token. There you can see that the subclaim of the original token becomes the name claim of DEX token, because we cannot just move the subclaim as is to the subclaim, because DEX has its own way to form the subclaim of the tokens, but we can put the value of subclaim from original token to some different claim. To enable it in DEX, you don't need to do anything, but if you want to enable only token exchange grant and forbid other grants, it's also possible to do it like this. And you need to define the connector. Connector is, as we discussed previously, the basic concept of DEX. If you defined a connector, you can use a token exchange. Token exchange is easy to understand because we have a real-world concept we are familiar with, all you know about currency exchange. It's easy to start because DEX is lightweight, it's easy to deploy. There is only little configuration required, so it's easy to configure, and this is a funny field for experiments. We are done with talking about what is token exchange. Let's move on and see some real-world cases that we can solve with this feature. The first case is CI/CD integration. The goal is to deploy to a Kubernetes cluster. We do it every day. We are deploying a lot of things to our Kuberneteses. And the common anti-patterns here, the first one is, everybody knows about this, extracting administrator configuration from the cluster and put it in your CI system. This is pretty bad because if the configuration file is stolen, you need to redeploy certificates in the whole Kubernetes cluster because there is no way to ban this specific certificate in Kubernetes. And it will be, of course, disruptive. And the other anti-pattern is using a service account token with an infinite lifetime to access Kubernetes from CI/CD system. This is also bad because there is no way to ban this token other than deleting certificate, other than deleting system, service account. But you need to ensure somehow that this service account will not ever be created. This is also not good. What we can do with token exchange to improve security of our CI/CD system? There are some actors, GitLab CI/CD, DEX, and Kubernetes. The first thing is that we are connecting DEX as OpenID Connect provider to our Kubernetes cluster. So now Kubernetes can validate DEX tokens, and DEX now is identity provider for Kubernetes. At this point, like GitLab, for each job execution, it issues a GitLab token. But with this GitLab token, we cannot access Kubernetes API because Kubernetes doesn't know about GitLab at all. But what we can do? We can we can connect GitLab as a provider to DEX. And now DEX can validate GitLab tokens. And in this point, DEX can exchange GitLab token to the DEX token. And now, the final moment of truth. When the job is executed, GitLab goes to DEX with GitLab token, receives back the DEX token, and with DEX token, GitLab can finally access Kubernetes API. This is how it works. It's not only GitLab, of course, that can be used in various CI/CD systems, like, for example, GitHub Actions as well, or in Jenkins also. And all major cloud providers allow authenticating using CI/CD tokens. For example, you may go with GitLab token to AWS and create machines here, but why can't you go to Kubernetes and create deployments here? With DEX now, you also can do this. And no more anti-patterns, of course. Moving forward, the second case is Kubernetes authentication mesh. It's a similar case. The goal is to give access to a service from one cluster to another cluster. When we may need this? I have two examples, real-world examples. The first one is Istio, because if you want to build a multi-cluster using Istio, you need to give control planes in each cluster access to the different cluster. You may do it with so the Istio is the first case. And the second case is Argo CD for rollouts. They also do so. They are also accessing other Kuberneteses. And common anti-patterns are the same, like extracting the administrator kubeconfig from one cluster and giving it to another cluster. This pretty much the same. What we can do in this situation? There are 4 actors now, DEX and 3 different Kubernetes clusters. The first thing that we are doing is connecting DEX to each Kubernetes cluster as OpenID Connect provider. So each Kubernetes fetch DEX keys, and now they all have keys of DEX and so DEX tokens can be trusted by all these Kubernetes clusters. And then, because Kubernetes has OpenID Connect endpoint, it can also be connected to DEX via connector as an authentication provider. So we are connecting all 3 clusters to DEX as providers. And now we have a full mesh, and each cluster can authenticate through DEX in other clusters. Now, we are wanting to go from the first cluster to a third cluster with a service account token. It's not possible, of course. But what we can do is to go with the service account token to DEX, and then exchange it for a DEX token, and go finally from the first cluster to the third cluster. A pretty complicated flow, I would say. How can we automate this flow? So in kubeconfig, there is a possibility to use exec credentials plugins, special executions file that return your authentication data, either certificates or tokens. And it's possible to write a simple script to interact with DEX and exchange tokens. I will show you how. So this is the simple example written in Bash. Don't judge me, please. This is the first thing. We are getting the service account token data. The next thing, we are sending request to DEX to exchange the service account token for a DEX token. And the third thing, we are returning the token the way kubectl wants us to return it. Then what we are doing, we are saving this script to the bin token exchange file. We are giving this script execution rights, and then we are providing this section in the kubeconfig file. And now will be automatically exchanging tokens of service account to DEX tokens. And with this token, we can access any Kubernetes cluster in this mesh. And of course, this is a not real-world production-ready example, you understand? But this is just to show you how it works. And yeah, and the third case, also interesting one, Spiffe tokens. There is this thing called Spiffe. This is a standard, and the standard is all about that all applications running in your cluster, they have to be authenticated. And there are Spiffe tokens, which we can use to authenticate applications. But why do we need to provide some additional authentication data, like, for example, service accounts, to authenticate our Kubernetes workload twice? Just doesn't make sense. So there is a way to use Spiffe tokens to access Kubernetes API. So the goal is to use Spiffe tokens to access to Kubernetes API. Yeah, there are a lot of different actors. There are two new things: Spire server and Spire agent. Spire is the Spiffe implementation. Don't mind it. Think about it as some server and agent. The first thing they are doing is registrating. So node agent registers in the server. This is the first thing. The second thing is that because Spire server has OpenID Connect endpoint, we can register it in DEX as a authentication provider. Next, we connect DEX, as we did previously 4 times already, to Kubernetes as OpenID Connect provider. And now the juicy part begins. Application goes to Spire agent and gets its Spiffe token. With Spiffe token, it cannot access Kubernetes API at the point, but it can exchange Spiffe token for a DEX token and finally have an access to Kubernetes API. And with this feature, you can use your role bindings like this. You can use just a Spiffe ID as the name of the user, and you can forget about using service account on Kubernetes. You may just delete them from your APIs. You don't need them at all, which is pretty mind-blowing as for me. It was the third interesting case, and I'm done for today. We have finally made it to finals. Let's wrap a little bit what we discussed today. The first thing is that the token exchange feature is a glue between different authentication providers. You may connect them using DEX. The second thing is that DEX is lightweight and can be used to add this capability to any Kubernetes with literally no overhead. From Kubernetes 1.29, you may add more than one OpenID Connect provider, so it's literally free. Not only DEX benefits from it, yet the whole ecosystem, because with this feature, DEX enables other applications from Cloud Native Computing Foundation landscape and makes them communicate with each other more securely. And if security features are convenient, it improves the security in the world in general. And this is what I wanted to say today. Thank you so much. This was my talk. Let's authenticate everything in this world. Thank you so much.
Thank you so much for this session. We don't have yet any question, but we'll still have a couple of minutes if some have some questions. Actually, I have one for you. What's your, how could I say, return of experience in implementing Spiffe in production? Meaning, is it like a long journey? Is it easy? What are the main point that we have to care about?
My answer will be that I'm not expert with Spiffe. I just played it with it a little bit in my home lab, and implementing it in production will be much more difficult.
So you would require implementing DEX in production rather than Spiffe, or?
I would say like Spiffe in general.
Got it. Any questions in the audience? Someone wants to grab the mic. Don't be shy. Raise your hand. Everybody wants to go to the after party. I'm pretty sure. All right.
The only question that, are we able to go now? I would say yes.
If we don't have any other question, then again, thank you so much for your session. Thank you all for joining.